Okay guys, you have to keep track of how I'm doing these because I cut and pasted to give myself more room to work, so they're a little out of order. But starting off with number 1, we are adding two functions, so it's just 4n minus 1 plus 3n minus 4, so you get 7n minus 5. That's your answer. Then on number 3, notice that we're going to evaluate the two functions, the composition at -7. So we start on the inside function. So h of -7 means I'm going to get -7 minus 2, which is a -9, and that's then going to get plugged into my g function. So when I plug that in, I've got -9 squared plus 1, which is going to give me 82. Okay, on number 5, we want to do the inverse function. So remember, we call this x, -15 plus 2x divided by 5, and then we want to solve for, this is a y, and we want to solve for y. So first thing I do is multiply both sides by 5 equals -15 plus 2y, so we'll have 5x plus 15 divided by 2 equals our inverse function. Okay, now down below number 2, now we get to our number 2. Remember, it's g minus h, so I'm going to write my g function first, minus, and I'm going to put them in parentheses so you don't lose that you have to distribute that negative to both terms. So when I do my subtraction, 2x squared has no other like terms over here, then minus 2x, I'll put it in form, and then we have minus 2 minus a -5, so that last term is going to be a +3. Okay, and now this last one we're actually going to do the composition of the two. So notice that g is the outside function, h is the inside function. So g is going to be the function I start with here, and I leave a space because h is going to go inside there. So 3x squared plus 1 squared minus 1. So you're going to FOIL this. So you have 9x squared plus 6x plus 1, and then minus 1 left over. And so your end result is that the minus 1's cancel, and your answer is 9x squared plus 6x. Okay? So let's go on to the next one. So then we have here 7. So we're doing the domain and the range deal. So remember how we talked about you look underneath the radical. Notice that it would be a -1. So we know that in terms of the domain, my x's have to be greater than or equal to a -1 because you can't have anything less than 0 under the radical. And if x is a -1, then y is going to equal 0 plus 1, which makes your y equal 1. So my range is going to be all the y's greater than or equal to 1. So -1, 1 is where I start, and because it's a positive graph, you just draw your graph like that. Okay? And on the other side, same kind of deal. So x equals 3 is the smallest value you can plug in there, so your domain will be all the x's greater than or equal to 3. And if I plug 3 in there, then y equals a -1. So y is going to be greater than or equal to -1 because it's positive in front of the square root sign. So I go to 3, -1, which is right here, and I draw my graph like that. Okay, now we're going to simplify 36x to the 4th y cubed, and it's a square root. So remember that means, well, the square root of 36 we know, that's 6. That's no big deal. Sometimes these are easier if you write it as a fractional power. So we're doing x to the 4th times a half. A half of 4 is x squared. It comes out. Then you're doing y cubed to the 1/2. Well, that's times 1/2, so that's y to the 3/2. So what we're going to do is we have y squared to the 1/2 times y to the 1/2. It's not working out so well with this pen. So that means a y comes out, but I still have a y underneath my radical. So you're going to break y cubed into y squared times y. The y squared comes out as y because the squaring and square rooting cancel. on number 10, now 250 is the same thing as 125 times 2, and realize that 125 is 5 cubed. So we have here 5 cubed times 2, m to the 4th you can write as m cubed times m to the 1, because that adds up to 4. N to the 6 is a multiple of 3, so we can write it as 2 times 3. So when you go to put your square root over all of them, or your cubed root I should say, this one cancels, so a 5 will come out. This one cancels, so an m comes out. And this one cancels, so n squared comes out. What's left are these ones I haven't touched. So we still have, under a cubed root, we have 2m. Alright, number 11, this should be pretty straightforward. You have negative 2 rad 5, because 4 times 5, plus 24 is 4 times 6, so this becomes 6 rad 6, and 2 rad 5 at the end. Can't be simplified, but the first and last terms do cancel out, so your final answer is just 6 rad 6. And what we have here is we need to rationalize. So remember, rationalizing means I'm going to have rad 3 plus 4, and on top I will go rad 3 plus 4. That's your conjugate, where everything's the same except for that middle sign. So on the bottom, remember you have a squared minus b squared, so that's going to be 3 minus 16. So my denominator is going to be a negative 13. And on top, I'm going to distribute. So we have 4 rad 5 times rad 3 is going to be 4 rad 15, plus 4 times 4 is 16 rad 5. And there's not really anything you can simplify because you got an odd number. So your final answer is this, and you can just leave the negative down there. Now this is just writing 13 just in exponential form. So you have 5k in parentheses, that is to the 2/3. The 3 is your root. Now 6p, we can leave the 6p in parentheses, and it is cubed, but we're taking the square root of it. So it's the way you would write it with a square root. Nothing terribly interesting there. Okay, so then we get down to 15. So remember, I always said do the bottom number first. So the square root of 81 we know is 9. All right, and x squared to the 3/2, realize that's like 2 over 1 times 3 over 2. The 2's cancel, and you're left with just x cubed. Number 16 here, we're going to take the square root of 9, which we know is 3, and 4 times 1/2 is n squared. Let's go ahead and simplify my numerator first. So, my denominator. So I have a 3 rad 2 on top. On the bottom, realize that 27 times 2 is 54. So I have the cubed root of 3. 3 cubed is 27, and the cubed root of 2. And so we know this will cancel to give me just a 3 downstairs, and the cubed roots of 2 cancel, so my final answer just simplifies down to 1/2. And over here, 8 times 3/4, well, 4 goes into 8 2 times, so you're left with r to the 6. And simplify. Okay, last slide. Number 19. So we have our radical isolated, so I'm immediately going to square both sides, and notice you're going to have a quadratic. So I'm going to have x squared plus x minus 12 when I move it to the other side. And when we work this out, you get x plus 4, x minus 3 equals 0. So x equals a negative 4 or a positive 3. When I plug it in, I would have a radical equals a negative 4. That can't happen, so your only answer is 3. On 21, I want to divide by 4 first. So I have x plus 4 equals 10. Then when I square both sides, I get x plus 4 equals 100, so x equals 96. And number 20, that's going to be, dun, da, da, for those of you who are watching, extra credit, dun, da, da. It's a problem that is not going to be a short problem. So yeah, that one's kind of like the other extra credit problem I gave you. So if you want to go ahead and do it, there it is. I'm not going to do it here. But realize I will help you. The first step, you do want to isolate your radical term, so move it to the other side and then start squaring. 23, we want to distribute and make sure we simplify in the end. So you're going to have 5 rad 5 times rad 10. Realize rad 10 is 5 times 2. And then plus 4 times 5 is 20 rad 5. So these two rad 5s come out as 5. So you end up with 25 rad 2 plus 20 rad 5. Okay? Now, let's look at what we have going on here at the bottom. So, perform the indicated operations. We're multiplying. So, I don't know why. I don't really need to go through this with you. Just be very careful when you're doing your FOIL, because you guys know how to FOIL. 6x squared minus 10x plus 9x minus 15, so your final answer would be 6x squared minus x minus 15. Now these last two are potential extra credit problems. The idea behind them is you have a fractional root here. So the idea is the same. We're going to isolate our radical, so that means I'm going to subtract 8 from both sides. And then I'm going to raise both sides to what would make this 1, which in this case is 2/3. Okay, so I end up here with k plus 17. Turns out that the cubed root of 1,000 is 10, and 10 squared is 100. So k equals a very friendly, what is that? That would be 83. There we go. Over here it's already isolated, so I'm just going to raise to the both sides 2/3, the reciprocal, so that cancels out. P minus 11 equals, it turns out the cubed root of 512 is 8. 8 squared is 64. So P is going to equal 64 plus 11, which is 75. Okay? So I am hoping that all this will tie in together and is all good. Okay?